Picture this. You're in a Snowflake interview, the panel leans in and asks you to explain the architecture, and your mind goes blank. I have watched brilliant engineers freeze on exactly 7 questions, not because they did not know Snowflake, but because nobody taught them to answer like an architect. So today we fix that nail, these sevens, and you sound production ready. In interviews, in client calls, in design reviews. This is not certification trivia, this is the architecture thinking that senior people actually use every day. Here is the whole map on one screen. Architecture, warehouses, pruning caches, recovery, loading and cost, 7 questions, and one single thread. Ties every one of them together, storage and compute are separate. Hold on to that idea, because every answer you give today will trace straight back to it. Screenshot this slide right now. It is your interview morning map. Take a look at the Snowflake architecture in one picture. There are three independent layers: one thinks, one works, one remembers. At the top sits cloud services. That is the brain, the optimizer, the metadata, the security in the middle, live the virtual warehouses. That is your compute. And at the bottom is storage. One shared copy of your data in cloud object storage. Think of a restaurant, one manager, many kitchens, and one shared pantry every kitchen pulls from. Now, why does separating these layers actually win? Two reasons that matter in production. First, concurrency. The buy team and the ETL team each get their own warehouse on the very same data. Second, cost. You pay for compute only while it runs. Storage stays cheap and constant in the background. And here is the line that lands in an interview. Do not say because cloud that says nothing. Say you scale the bill to the work, not the data. That sentence sounds like an architect. Question 2. Do you scale up or scale out? This is where so many people trip. So let me give you a clean rule. One slow single query. You scale up. A bigger warehouse size gives that one query more horsepower, but queries piling up and waiting in line. You scale out. That means multi-cluster, more warehouses running in parallel. And here is the trap they are listening for. A bigger warehouse never fixes a concurrency problem. Size is speed, clusters are concurrency. Let me make that real with a scenario you have probably lived. It is 9 a.m. Your ETL jobs are loading the warehouse, and at the same moment, the buy dashboards crawl to a halt. Same warehouse, one shared queue, everyone waiting behind, everyone the wrong fix is to size up. A bigger warehouse is still one single line. The right fix is separate warehouses or multi cluster. Now each team scales completely on its own, and they still read one shared copy of the data underneath. Here is what that looks like in actual code. You create a warehouse, give it a size of small, set auto suspend to 60 seconds, and turn auto resume on. The intent is simple: spin up when work arrives, go to sleep when it is idle. And when you need concurrency, you add a minimum cluster count of 1 and a maximum of 3. Snowflake spins up extra clusters only when the queue grows. One gotcha to remember: set auto suspend too high, and you have an idle warehouse billing you for absolutely nothing. Question 3. How does Snowflake skip data? It does not need. Every table is automatically split into micro partitions, and each one stores the minimum and maximum value for every column. So when you filter on a date, Snowflake reads that metadata first, and it skips every partition that cannot possibly match. Picture a bookshelf organized by genre. You skip whole shelves at a glance. You never scan every single book. That skipping is called pruning, and on this slide, filtering one date reads just 2 partitions out of 10. So when should you add a cluster key? Only for big tables that you filter on a column they are not naturally ordered by. The command is short. You alter the table and cluster by event date. Then you check the clustering information function to see how well organized it is. But here is the gotcha that separates seniors from juniors. Clustering costs credits, it is not free. So measure your pruning in the query profile first. Prove you have a problem before you spend money fixing it. Question 4. The 3 caches. Snowflake has 3 and they live in different places. First, the result cache up in cloud services. Second, the local SSD cache inside each warehouse. Third, the metadata cache holding those min and max stats. When a repeat query is eligible, Snowflake can skip the recompute entirely and hand you the answer much faster. But eligible is the keyword. Result reuse needs unchanged data and matching conditions. It is not a blanket rule. Knowing that nuance is exactly what they want to hear. Let me give you a debugging scenario. A query that was fast yesterday is suddenly slow. Today what happened? Option 1. The data changed, so the cached result is no longer eligible and the query actually runs from scratch. Option 2. The warehouse auto suspended, so the local SSD cache went cold and it has to reread everything from storage, and the fix, a small always on warehouse for the latency sensitive dashboards. Diagnose the cache before you blame the query. Question 5. Snowflake versions your data. This is a beautiful one to understand. Snowflake never overwrites a micro partition. It versions it, the old version stays. A new one is written, and that single fact powers two features at once. Time travel lets you go back, and zero copy clone lets you branch. Here is the pro move. Even if they ask you about only one, answer both, because it shows you see the link between them. That is architect level thinking. Time travel is the undo button for your database. Drop the table by accident. You simply undrop it. Want the data as it looked 1 hour ago. You select from the table at an offset of negative 3600 seconds. Standard time travel gives you 1 day, and you can extend it up to 90 days, but that needs enterprise edition or higher. And the gotcha, longer retention means more stored versions, which means more storage cost. Power has a price, and you should know it. Monday morning, zero copy clone is Git for your data. You create a table called orders dev as a clone of orders. It is instant and it uses no extra storage until something actually changes. The clone shares the same partitions as production, only the difference costs anything, exactly like a Git branch. And think about what this unlocks. Every engineer on your team gets a production size sandbox in seconds. No waiting, no copying terabytes. Just branch, experiment, and throw it away. Question 6. How do you load data and do change data capture? First, a mindset shift. It is ELT, not ETLU. You land the raw data first, then transform it inside Snowflake. For batch loads, you stage your files and use copy into for continuous loads. Snowpipe auto ingests new files the moment they arrive. And for change data capture, streams track what changed. While tasks run the merge on a schedule. Land it, transform it, keep it incremental. Here is the incremental pattern in code. You create a stream on the raw orders table. That stream quietly tracks every change. Then you create a task on the ETL warehouse, scheduled every 5 minutes, that merges those changes into your clean table. The intent is a hands-off pipeline that keeps clean data fresh, and one subtle gotcha that catches people consuming a stream advances its offset. So read it inside the task, read it anywhere else, and you will lose track of your changes. Question 7. Controlling the bill, and the strongest answers have two halves, prevent and detect. To prevent waste, you right size your warehouses, you set auto suspend, and you put resource monitors in place. To detect waste, you go find the credit hog inside account usage. And here is the structure that reads senior, lead with the guardrails, finish with the diagnostics. That arc from preventing to detecting tells the panel you have actually operated this in production. Let me show you the guardrail in code. You create a resource monitor with a credit quota of 1000 and a trigger that suspends the warehouse at 100%. That is a hard ceiling on spend. Now a teaching heuristic, not real pricing. An extra small warehouse is roughly 1 credit per hour and each size up roughly doubles it. So size matters fast, and one gotcha to know cold. Suspend lets running queries finish, suspend immediate, kills them on the spot. Choose deliberately. Now, the detect side, finding the credit hog. You query account, usage, pull the query ID, the warehouse name, and byte scanned, and order by total elapsed time descending. The worst offenders float right to the top. Here is an illustrative example. One query scans roughly 2 terabytes. A pruned version scans roughly 60 gigabytes. Far fewer bytes, same result. And saying I would check account, usage before anyone even asks tells them one thing clearly. You have actually operated Snowflake. Here is your 7 question cheat sheet. Architecture, 3 layers, storage and compute separate warehouses. Size is speed, clusters are concurrency, pruning, micro partition skip data, caches, result local and metadata, recovery time travel plus zero copy clone loading in leading, LT with streams and tasks, and cost monitors plus account usage. Screenshot this one, this is your whole interview on a single card. Let me give you a framework that works on any Snowflake question they throw at you. Name it, then say why it exists, then give the command or the rule, then name the gotcha. Most people miss what, why, how gotcha. That rhythm is exactly how senior engineers think out loud. And here is the secret. It is also how a good code review sounds, which is the real job waiting on the other side of the interview. So look back at where we started. 7 questions that freeze most candidates, and every single answer traced back to one idea. Storage and compute are separate. Hold that thread and the rest follows. Now knowing the answers is the start. Building it for real is the leap. That is the full Snowflake masterclass link below. And if you want the pipeline cost and Snowpro deep dives, subscribe and stay close. One last thing, drop the toughest question you have ever been asked in the comments.